This video will cover Chapter 6, Section 2. This is Part 3. Alright, so our next example, we're going to find the exact value of the 6 trigonometric functions of pi over 6, or 30 degrees. So remember that we're going to reference the coordinate square root of 3 over 2 and 1/2. So sine of 30 degrees is a half. Cosine of 30 degrees is square root of 3 over 2. Tangent of 30 degrees is going to be 1/2 divided by square root of 3 over 2. Now recall from the last video, I said if the denominators are ever exactly the same, they're going to divide out, and then you can reduce down to what's left. But in this case, we have 1 over square root of 3, so we want to rationalize that. Multiply top and bottom by the square root of 3, so this is going to be 1 times the square root of 3 divided by the square root of 9, which is just 3. Okay, and then the cosecant of 30 degrees is the reciprocal of sine, so that's 2. The secant of 30 degrees is the reciprocal of 2 over square root of 3. And rationalize it, so that's 2 square root of 3 over 3. And then the cotangent of 30 degrees is the reciprocal of tangent. So I'm just going to go back to what I had originally. So if I go from here, I don't need to rationalize it again because I can just flip that over, and that gives me square root of 3 over 1. Now this slide just summarizes the 6 trigonometric values for pi 6, pi 4th, and pi 3rds. So next we're going to talk about how we fill out the rest of the unit circle. So I'm going to go back to our blank unit, well, semi-blank unit circle at this point, and let's talk about how we fill out the rest of it. So basically we're going to use properties of symmetry to figure out what these values are. So let's start with all the multiples of 45 degrees. So at 45 degrees, in the first quadrant, I have square root 2 over 2 as my x and square root 2 over 2 as my y. Now, as I move into the second quadrant, I know that when I'm on the opposite side of y, the x values are negative and the y values are positive. Okay, so using symmetry, this is just going to be a reflection over the y-axis. So the x value is going to be negative square root 2 over 2, and the y value is going to be positive square root of 2 over 2 for that 3 pi force angle. Okay. Now, if I reflect that down into the third quadrant, I'm looking at 5 pi force. So in the third quadrant, not only is x negative, but y is also negative. So this is going to be negative square root of 2 over 2 and negative square root of 2 over 2. Now let's go back to the fourth quadrant. So if this is reflected across the y-axis, then I'm looking at 7 pi force. So in the fourth quadrant, x is positive, but y is negative. So this is going to be square root of 2 over 2 and negative square root of 2 over 2. Now, I want you to pause the video using just this part of your unit circle. Find the exact value of each of these 4 expressions. All right, so let's take a look. So I don't have to flip back and forth between the unit circle and my document. I've just put that reference coordinate above each of these. So at 5 pi force, we are looking at the coordinate negative square root of 2 over 2 and negative square root of 2 over 2. So sine is the y value, so the value of sine 5 pi force is negative square root of 2 over 2. Cosine at 135 degrees, that coordinate that we're referencing is negative square root of 2 over 2 and positive square root of 2 over 2. Cosine is the x value, so that's negative square root of 2 over 2. Cotangent at 315 degrees, the coordinate that we're referencing is square root of 2 over 2 and negative square root of 2 over 2. Cotangent is x divided by y, So if I take my x coordinate and divide it by my y coordinate, that gives me -1. And then cosine of negative pi fourths. Now, negative pi fourths, remember you're rotating this way, pi fourths unit. So that's going to be the same as 7 pi fourths. So that's exactly the same of cosine 7 pi fourths. So the coordinate that we're referencing is the same one as we did here, because that's 315 degrees. And the cosine is the x value, so that's square root of 2 over 2. Now it's time to look at the integer multiples of pi sixths and pi thirds. Okay, so once again, using this idea of symmetry that we talked about when we were doing the multiples of pi fourths, I can reason that these are going to be similar. So at pi 6, which is 30 degrees, if I reflect that point over the y-axis, that puts me at, now this is in radians, so pi 6, that's going to put me at 5 pi 6. And so those values are going to be the same initial values, but the signs, S-I-G-N signs, are going to change as you change quadrants. Okay, so in the second quadrant, x is negative. In the third quadrant, both are negative. And in the fourth quadrant, y is negative. Okay, so you can see all of these are the same basic value, but some have, instead of being positive, they're negative. All right, so at pi thirds, same thing. We have this idea of symmetry and reflection going on. And so if we reflect this point across the y-axis, that puts us in the second quadrant. And once again, the second quadrant, x is negative, y is positive. In the third quadrant, both are negative. And in the fourth quadrant, only y is negative. So using these values, we can go back to our unit circle and finish filling in those values. All right, so I've pulled up a better copy of the unit circle. This is a completed one that is nice and printed, so you don't have to read my handwriting. So take a minute to go through and double check all the values that we have filled in for all 4 quadrants. And make sure you're focusing on not only the value, but which coordinate is positive and which one is negative, because if you get those mixed up, that's going to throw off your answers when you're trying to work problems using this unit circle. So you can pause the video as you check the upper half of your unit circle. And then I'll move it down so you can check the lower half of your unit circle and just pause the video if you need to. Now the last thing that we have to fill out on this unit circle, let me scroll back up, which trig functions are positive and negative in each of these 4 quadrants. So in the first quadrant, everything is positive and none of them are negative. In the second quadrant, the sine functions, because those are the y values, sine is positive and cosecant, which is its reciprocal, is positive. Everything else is negative. In the third quadrant, tangent and cotangent are going to be positive because they're going to be the quotient of the x and y, or y and x. And then everything else is going to be negative. And in the last quadrant, the fourth quadrant, cosine and its reciprocal is positive and everything else is negative. All right, so now that we have our entire unit circle filled out, let's practice the skill of finding the exact value for different special angles. So we're going to start with cosine of 210 degrees. So if you've got your unit circle in front of you, I want you to locate 210 degrees. We're going to write down that reference coordinate. That's the negative square root of 3 over 2. and negative 1/2. Now, we want the cosine, which is the x value, so that's negative square root of 3 over 2. Okay. What about the sine of negative 60 degrees? So if you rotate in the negative direction 60 degrees, that's going to put you at positive 300 degrees. So you can just change that into its coterminal angle and put it back into the unit circle. But that's going to be 300 degrees. And its coordinate that we're going to reference is 1/2 and negative square root 3 over 2. So we want the sine of that. So sine is the y coordinate. And that gives us negative square root of 3 over 2. Now, what about tangent of 5 pi thirds? So tangent of 5 pi thirds, so let's write down that coordinate. Turns out it's the exact same one from part B. So 1/2 and negative square root of 3 over 2. Now, tangent is the y over the x, so this is negative square root of 3 over 2, divided by 1/2. We talked about this earlier. Those 2's are going to divide out. And when I reduce what's left, that's just negative square root of 3. And then cosine of 8 pi thirds. Okay, so you'll notice that 8 pi thirds is not in your unit circle. So this is more than 1 revolution. So if I want to find the coterminal angle, so I want to bring this back into the unit circle, what I need to do is take 8 pi thirds and I want to subtract 2 pi. So I have to put 2 pi in terms of a third. So if I convert 2 to a third, that's actually going to be, I'm just going to mark that out, 6 pi thirds. So 8 pi thirds minus 6 pi thirds is actually 2 pi thirds. So this is going to be the same thing as cosine of 2 pi thirds, which is now inside my unit circle. So if we look for 2 pi thirds, that's the same thing as 120 degrees. That coordinate is negative 1/2 and square root of 3 over 2. We want the cosine of that, which is the x value, so that's negative 1/2. All right, so let's take a look at the following. Find the exact value of each without using a calculator. So no calculator, just your unit circle. Okay, so using your unit circle, find the value of sine of 90 degrees. Got it? So sine of 90 degrees is 1. We're going to add that to the tangent of 45 degrees. So tangent of 45 degrees is 1. So that gives us a value of 2. Okay, now you're using your unit circle. Secant of 30 degrees. Now remember that secant is the reciprocal of cosine. Cosine is x. So the secant of 30 degrees, you're going to take the x-coordinate and flip it upside down. So that's 2 over the square root of 3. Now, I'm going to hold off about rationalizing that. I'll rationalize it at the end when I see what my final answer is going to be. Cotangent of 45 degrees. So cotangent is x over y. And that's going to be 1. So this is going to be 2 over square root of 3. So I am going to have to rationalize. I was hoping maybe something would cancel out, but it didn't. So I'm going to rationalize it. Square root of 3 times square root of 3, square root of 9, which is 3. So that answer is 2 square root of 3 over 3. See, now that's an answer your calculator wouldn't give you because it's in terms of the square root of 3. So a calculator would not be helpful there because we want the exact value, not the approximate value. Okay, so for the last one, we have 2 times. All right, so 2 times. We want the sine of pi fourths. So that's going to be square root of 2 over 2 plus 3 times the tangent of pi fourths. That's going to be a 1. And that's going to divide out. So this is going to give us square root of 2 plus 3 times 1 is 3. So square root of 2 plus 3. So once again, a calculator wouldn't help you there because it would turn that into a decimal. And we don't want a decimal. We want the exact value. Okay, very good. Let's move on. In our next example, we're going to use a calculator to approximate the value of a trigonometric function. Now, I don't have a calculator on my laptop where I can pull it up and show you how to do this, but I do have what it looks like on your calculator. So work along with me. Use a calculator to find the approximate value of the following trig functions. So my first one is sine of 48 degrees. So before you put this into your calculator, you're going to want to go to your mode. So find your mode key. And then you want to scroll down to where it says radians degrees. You want to cursor over to degrees and hit enter. So you've set your mode to degrees. Now you can quit out of that. So do a second quit. And then go back to the home screen and type in sine of 48. Okay, so when you type in sine of 48, it's going to give you this decimal. We're going to round to 2 decimal places, so we're going to look to the 3rd decimal place. That is less than 5, so I'm going to round this to 0.74. Okay. Now, if you notice on your calculator, you have a sine, cosine, tangent key. You do not have a secant. Now, for our next one, this is secant of 21 degrees. So leave your calculator in degree mode. Okay. So for secant, you want to do 1 over, since it's reciprocal, 1 over cosine of 21 degrees. And that gives you 1.07 if we rounded 2 decimal places. Okay, so to find secant, cosecant, and cotangent, you're going to do 1 divided by. Now, this is only going to be used in the case where we are not using a special angle, or the problem wants the answer in decimals. Okay, now I want you to go back to your mode and go down where you put your calculator in degrees. I want you to change it back to radians. So cursor down to radians and hit enter to choose radians, and then quit out of that. And let's go back to your home screen. So do a second quit, which is actually second mode is your quit key. So do a second mode to quit and go back to your home screen. And then you're going to do tangent of pi over 14. Now your pi key, if you look at your calculator keys, you'll see one that says clear. The second function of the key that's underneath that's your pi. So that little symbol is called a caret. It looks like this. So the second function of that key, which is directly underneath clear, is your pi key. So type in tangent of pi over 14. And if you round that to 2 decimal places, since the 3rd decimal is an 8, this is going to round to 0.23. Now, these trig values that we've been talking about, we have looked at these as they apply to a unit circle. But they actually apply to a circle of any size. So it doesn't always have to be a unit circle. You don't always have to have a radius of 1. So the following definitions are going to allow us to find the 6 trigonometric functions for an angle in standard position of a circle that is not a unit circle. So in other words, it is x squared plus y squared equals r squared. Okay, so in these definitions, we're going to replace 1 with r. So our sine is going to be y over r. So before it was y over 1 because the radius was 1. Now it's over r. So now the radius can be anything. Cosine is x over r. Tangent hasn't changed. It's still y over x, as long as x isn't 0. Cosecant, still the reciprocal of sine, so it's r over y, as long as y is not 0. Secant is still the reciprocal of cosine, which is r over x, as long as x isn't 0. And cotangent is x over y, the reciprocal of tangent, as long as y is not equal to 0. Now, in example 12, we're going to be finding the 6 trigonometric functions for a coordinate that is not in the unit circle. Okay, so you need to be very careful when you're practicing these skills in your homework, because if you're trying to use the unit circle definitions for a coordinate that's not on the unit circle, you're going to get everything incorrect except for tangent and cotangent. So anything that needs an R, if it's not 1, you're going to miss those questions. So be very careful to read the question and make sure you're using the correct definitions. So find the exact value of each of the 6 trigonometric functions of an angle, theta, if 4, -3 is a point on the terminal side in standard position. Okay, so I have x equals 4, y equals -3. Now the first thing I want to do is find r. So here's what I'm going to use. If I do x squared plus y squared equals r squared, and I allow x to be 4, so that's 4 squared, y is -3, so that's -3 squared, equals r squared. 4 squared is 16, 3 squared is 9, 9 and 16 is 25. And then if I take the square root of both sides, that's going to give me 5. Now, I did not make this plus or minus like I have in the past because the radius is a measure of the third side of that right triangle, or the measure of the radius of the circle. And so since it's a measurement, we're not going to use the negative. Okay, so it's just 5. Now, if you don't know whether or not your coordinate is on the unit circle, you can always go through this calculation to find r, and if r is 1, then your coordinate is on the unit circle. If not, then you're going to have your r that you can use the alternative definitions for. Okay, so let's find those 6 trig values. So sine, and then I don't know the angle, so I'm just going to use theta. So sine theta is y over r, so that's -3/5. Cosine theta is x over r, so that's 4/5. Tangent theta is y over x, so that's -3/4. Cosecant theta is the reciprocal, so that's -5/3. Cosine's reciprocal is secant, so that's 5/4. And then cotangent is a reciprocal of tangent, so that's 4 negative, well, the negative should be on the top. Let me move that up to the top. So -4/3. Okay, now one thing I want to double check before I leave this problem, let's take a look at what quadrant this coordinate's in. So +4, -3, that puts us in quadrant 4. So let's double check those signs just to make sure. So in quadrant 4, cosine and its reciprocal are positive values. So cosine and secant are positive. Everything else should be negative. Okay, let me rewrite this so that's not confusing. So -4/3. Okay. All right, so everything else should be negative. Okay, so that is the 6 values, or 6 trigonometric values for a coordinate that's not in the unit circle. Okay, so I'm going to give you one to do on your own. So you will pause the video and work through that problem, and then you'll restart the video to check your work. So your problem is going to be find the exact value of each of the 6 trigonometric functions of an angle theta if negative 2, 3 is a point on its terminal side in standard position. So notice this problem did not mention the fact this coordinate is on the unit circle. So unless it says it's on the unit circle, you just assume it's not, and then you have to find the radius to find the values of the trig functions. So pause the video while you work through this, and then come back and check your work after you're done. Okay, so using negative 2 as x and 3 as y, we're going to plug that into our formula to find r. Negative 2 squared is 4, 3 squared is 9, that gives us 13. You're going to take the square root, and r is going to be the square root of 13. So sine is going to be y over r. We're going to rationalize that. So our final answer is 3 square root of 13 over 13. Cosine is x over r. You're going to rationalize it. So your final answer is negative 2 square root of 13 over 13. And tangent is y over x. So negative 3 over 2. Cosecant is going to be the reciprocal of sine. So when I flip that over, I will not need to rationalize it because I'm going back to my original. So if you flip this one over, then you'll have to rationalize it again. So go back to an easier point in the problem and choose the value where you don't have to rationalize. Secant is the reciprocal of cosine, so that's negative square root of 13 over 2. And then cotangent is the reciprocal of tangent, which is negative 2/3. That kind of looks like a 5, but that's a 3, negative 2/3. Now, before we leave this problem, once again, let's double check our signs. So negative 2, 3, that's going to be in the second quadrant. In the second quadrant, sine in its reciprocal is positive, and everything else is negative. So that all looks good. All right, so this is the end of section 6.2.